Welcome back, students. Now in this part, as I told you earlier also, that I'll be telling you about carbon family, the most abundant element which is present in this whole universe, right? And which has forced you to learn one more book of chemistry, that is organic chemistry. So here I'll be discussing the properties, okay, like physical and chemical properties of the whole group. And I will be telling you that what happens if I move on from top to bottom in that whole group. So here we go. Next, guys, our topic is carbon family. So I told you also earlier that this element, the carbon, has created a huge revolution in the world of chemistry, and which created a different book also for you guys of organic chemistry. So let's check it out, that what are the properties of the whole group, So this whole group, which consists of carbon, silicon, germanium, tin and lead. And your carbon and silicon, they are what? Your non-metals, okay? Germanium is a semi-metal or a metalloid, whereas tin and lead are metals. Even your carbon and silicon, they will also show sometimes property of a semi-metal or metalloid. And all the elements, they have 4 electrons in the valence shell. So the configuration is what? NS2 and P2. NS2 and P2. And your carbon and silicon, they are the most abundant elements in the group in the earth crust, even in the earth crust also. That's why your carbon, if you just observe the definitions also, right, whether of mole concept, whether of atomic mass, yeah, so they all are defined with respect to carbon. It's because of the abundance of the carbon. Now general trends, if I look for physical properties, so they are like this. Configuration will be 2s2 2p2, 3s2 3p2, like that, okay, 4s2 4p2, 5s2 5p2 and all. Then common oxidation state, again +4 is the common oxidation state, okay. But if you go below, means down the group, then +2 also comes, because that is more easier to lose the electrons. Atomic radius, again it will increase, okay. First ionization energy, it will decrease down the group. And your electronegativity, it will also decrease on the group. So it's kind of similar trend which we have observed in the boron family also. Now this property makes carbon a very honored metal. The property is of catenation, due to which it may form chains, it may form rings, okay, and on going down the tendency it decreases. Okay, so carbon is the highest, then silicon, then germanium, then tin, then lead. And due to this high tendency, okay, it forms many compounds, which are here also it's written, studied in organic chemistry. So a separate book for you guys, which this carbon has made, okay. One more property is there of allotropy. So this is that property which makes the compound to exist in 2 different forms. Okay, like about diamond and graphite. Okay, diamond and graphite, they have different features, but they are the same form of carbon. They are different forms of the same element, carbon. So it is existence of the element in 2 or more forms. Okay, which are significantly different in the physical properties, but have same chemical properties. So it's like if you take diamond, the carbon is sp3 hybridized and it is a tetrahedral kind of thing. It's very solid. And graphite, the carbon is your sp2 hybridized. And due to this, you have free electrons, okay, graphite, which makes it a conductor. But diamond is totally hard. It is very hard. And this sliding property of graphite also is because of the sp2 hybridization, okay. And it has the application as a lubricant oils also. Now, if I talk about the chemical properties, then again hydrides come. So carbon form cyclic and acyclic hydrides, we all know, right? So they are known as what? Hydrocarbons. They are known as hydrocarbon. There can be alkanes, alkenes and alkynes. Alkynes. The general form are CnH2n plus 2, CnH2n and CnH2n minus 2. Here it should be N. Okay, not 2. And silicon and germanium also forms few hydrides of the formula this MnH2n plus 2. Okay, MnH2n plus 2. So M was your metal, whether it is a silicon or germanium. And N value for silicon is from 1 to 8, while just make a note here that N value for germanium in Mn, okay, in Mn H2n plus 2, for germanium it is from 1 to 5. Okay, so these are known as silanes and germanes. I'll teach you silanes also, okay, short while. So only one hydride of tin which is known, that is your SnH4. That is your SnH4. And your thermal stability, it will decrease down the group. It will decrease down the group. While you're reducing characters, it will increase down the group. If I talk about oxides, it forms monoxides and it forms dioxides. So monoxides, you know, carbon monoxide, germanium monoxide, tin monoxide, right? Your CO is neutral, otherwise all are basic in nature. And your CO is very, very harmful. Very, very injurious to health also. Because it sticks with hemoglobin pigment, if you remember. Next is dioxide. So your carbon dioxide, SiO2, GeO2, SnO2, PbO2. So they form monoxide and carbon and your dioxides. And among these, your carbon dioxide and SiO2, they are acidic, and your germanium, tin, they are what? Amphoteric in nature. They may be acidic also, they may be basic also. And your lead oxide, that is a base. That is a base. Now there is something called carbon suboxide, C3O2. How is it? What is the structure? Let's see. So in addition of carbon as CO and CO2, okay, we have C3O2. Okay, it is also formed by the carbon. It is like this. You have a malonic acid, COOH, CH2COOH. If I heat at 150 degrees Celsius with P4H10, so I get a, you can see here, this is C3O2. So this also carbon shows. This also carbon shows. If I talk about halides, so this form MX4 type halides, okay. Carbon also form MX2 type, and their stability are in this order. It decreases down the group. It decreases down the group, the halides stability. So first carbon, then silicon, then germanium, then tin, then lead. If you have any doubts in this chapter, you can log on to www.askIITians.com. There you can go to our discussion board and you can post your question by choosing your category. You have to select your category and you can post your question here. We experts at Ask IITians will answer to your question or doubts within 24 to 48 hours. So students, in this part we saw that the property like of catenation and allotropy of carbon makes it very much evident in the whole universe. So with the catenation property, it can form many compounds. It can form many compounds. That's why we have that book of organic chemistry, right? Also, we saw various properties like oxidation state, ionization enthalpy, electron gain enthalpy of this. Also, we saw the oxides. In what way my carbon exists as oxides. So there was one thing, suboxide, right? If you remember. Now in the next part, I will be telling you about carbon family compounds. Carbon family compounds, which generally will be consisting of all the silicates, silica thing. So stay tuned with me for the next part.